4. Okay. So, the nearby value for this is the degree Fahrenheit is found to minus 459.4 is approximately equals to the first equation, that is first one, minus 459.67 degree F. Actually, children, the thing is that approximate value of a Kelvin scale is 273 Kelvin we are giving, but the generalized value is 273.15 Kelvin. So, as we have ignored those decimals, you are getting an approximate value. Okay, children? Well, so what is the correct answer? 0 Kelvin in Fahrenheit scale is taken as minus 459.4 or minus 459.67 degree Fahrenheit. So, let us move to the next question, that is second one. At what temperature on the Fahrenheit scale will the reading be double of the reading on the Celsius scale? So, you are asked to compare the relation between the Celsius scale as well as Fahrenheit scale. So, the relation between the Celsius scale and Fahrenheit scale is given as C by 5 is equals to F minus 32 upon 9. So, according to the given condition, Fahrenheit scale will be the reading be double of the reading on the Celsius scale, given that the value of F is equals to 2 times of C. Suppose if you consider the C reading as X, then it implies that the F reading will be 2 times of X. Substituting these values in the above equation, so C X upon 5 must be taken as, instead of F, 2x minus 32 upon 9. Cross multiplying, we have 9x equals to 10x minus 160. This is x, children, not multiplication symbol. 10x minus 160. Bringing the 9x to the other side, we have 10x minus 9x is x is equals to 160. So, if x is found to be 160 degrees, you are asked to find the value of 2x. What temperature of the Fahrenheit scale will be? So, in order to find out the temperature of the Fahrenheit scale, since x is found to be, the reading on the Fahrenheit scale is 2x, that is 2 into 160, and this is equals to 320 degree F. And the correct option is option 4, that is 320 degree F. So, this is the original relation, children. If you consider the reading on the Celsius scale as some x, then Fahrenheit scale, according to the relation, they gave it as double that of the Celsius scale, so 2x. Substituting all those values in the given formula, you found the value of x as 160 degrees, but as you need to find the value of 2x, 2x is found to be 320 degree Fahrenheit. Okay. So, now moving to the next question, that is question number 3. The reading of centigrade thermometer coincides with that of the Fahrenheit thermometer in a liquid. So, both the readings on the Fahrenheit as well as Celsius scale is given to be equal. If that shows an X reading, this must also shows an X reading. So, the temperature of the liquid is the same formula we will be using, children. What is the formula? C upon 5 must be equals to F minus 32 upon 9. So, in the given condition, they gave that if C indicates X, then F must also indicate X, and you are asked to find the reading X. So, substituting in the above formula we have, instead of C, I can replace it with X upon 5 must be equated to F is also taken as X minus 32 upon 9. Cross multiplying, you get 9x is equals to 5x minus 160. The further simplification gives 5x taking the other side, 9 minus 5 is 4x. So, 4x is found to be minus 160, or x is found to be minus 160 upon 4, or x is found to be minus 40 degrees Celsius. The same will show as a minus 40 degree Fahrenheit. Hence, the correct option is option 1, that is minus 40 degrees Celsius. Okay. Fourth one, the steam point and the ice point of a mercury thermometer are marked as 80 degrees and 20 degrees. Some thermometer they have given us, they didn't mention with what type of scale they have given. So, let us understand this as some unknown scale. Okay, what will be the temperature in centigrade mercury scale? You are asked to compare that unknown scale with the centigrade scale when this thermometer is 32 degrees. But we know the concept that thermometric scale minus LFP upon UFP minus LFP always remains constant. So, in the new scale, if you consider, for the new scale, let us represent that scale as some x, and the reading of x is given as your 32. Thermometric scale reading is given as 32 degrees F. LFP of which is given as 20 degrees, whereas UFP is given as 80 degrees. But we know the formula between any two scales, if comparable, is thermometric scale. If you consider Celsius scale, C minus 0 upon 100 minus 0 must be constant, is comparable to the new, means new scale minus LFP of the lower new scale is 20 upon 80 minus 20. So, simplifying further, you get it as C minus 0 is C upon 100 is equals to x. The value of x, they have given it as 32 minus 20 upon 80 minus 20. Or C by 100 is found to be 32 minus 20 is 12 and 80 minus 20 is 60. This goes 5 times. Hence, the value of C is equals to 100 upon 5 and this is equals to 20 degrees Celsius. Hence, the correct option is option 1, that is 20 degrees Celsius. Okay, children. So, this is a new scale. That new scale thermometric reading, I named it as x, and the value of x is given as 32. Substituting all other values, you got the value of the centigrade scale as 20 degrees Celsius.